All right, here we are continuing our Penny for Your Thoughts activity, and we're going to bring together some of the different changes that we saw and classify them. We're going to start getting into some real chemistry. So our objectives here is to understand that when a chemical change or a chemical reaction occurs when atoms bond to different things, they switch partners. Like if you had an atom bonded with one thing in a chemical reaction, it's going to be bonded differently. And as we go on through the year, we're going to discuss a lot of those differences. We should be able to determine if a change is chemical or physical based on an equation. We should be able to determine if the change is chemical or physical based on molecular modeling, similar to what we did. We'll see pictures of the molecules before and after. You guys should be able to tell me pretty easily if it's a chemical or physical change. And lastly, we should understand that a physical change is when our particles move around in a different way, but the particle itself is still the same. So here's a little cartoon that I like. I like to steal things from the Cartoon Guide to Chemistry. You guys, I love it. It's a cool book, and I highly recommend that, I think they might have a copy in the library. If you want to take a look, check it out. If you don't, that's okay. I'll be bringing it into the classroom a little bit. So basically, this is how chemistry started. You had I'll let you guys take a second to read this, and I'll stop recording. But here we go. So this cartoon is just a diagram showing how way back when people would take these rocks, or as we called earlier, ores, heated them up, and they made copper metal or other metals, and that's essentially how we became a society. And there's also tons of other things that we figured out, and that chemistry helped us become what it is today. They take rocks and get iron out of it. They made bricks out of mud. They took fat and ash, and they made soap. They curdled milk into yogurt, fermented grain into beer, made cabbage into kimchi. So these are all things, tons of things, that we see applications of chemistry. When atoms switch partners, in the Penny for the Thoughts demo, we tried to take a penny and turn it into gold. We just talked about this. Not possible. So let's talk about why, in the foundations of chemistry, that it's not possible to take copper and turn it into gold. Okay? So you guys don't have to copy this second bullet down. Okay? So just I don't want to run out of time, so I'm going to keep. I'll pause it for a second, and then we'll keep moving on. So chemical and physical changes. You should definitely write this down. This here is very important. Okay? A chemical change.
Should I write this?
Yes, definitely write this. This is a key thing that I expect you guys to know forever. Okay? Chemical change. Why don't you guys just listen up for a sec, and I'll pause it. You guys can copy it down after. Okay? So a chemical change is a new substance is formed. You don't have the same substance as you began with. The atoms are bonded differently than they were in the beginning. And a new type of particle is made that wasn't present before. These are all related. A physical change. An example of a chemical change. One of my favorite chemical changes you guys studied before in biology. It happens with plants. What is that called? Photosynthesis, in which plants and other organisms do it too. So there's some photosynthetic bacteria and microbes. So what they do is they take H2O, normal water, and react it with CO2, carbon dioxide gas. Blah, 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 lots of different complex processes, enzymes, electrons move around in light. And what do you get? Sugar and oxygen, which is part of the reason why life evolved the way it did. That's my favorite chemical change. I also like cellular respiration too, but my favorite's photosynthesis. What's yours, Mr. Costa?
My favorite chemical reaction?
Yeah.
Burning gasoline.
Ah, I like that one too. Combustion of gasoline in your gas tank on the way here. Physical change. The substance remains the same. The atoms were bonded in the same way they were originally in that particle. And what the particles do is they change position. Particles change position in a physical change. It's the P's. Particles, position change, physical. So I'll give you guys a second. My favorite physical change is ice melting. I like the spring. You start off as solid water particles, and then it breaks up into liquid water particles. So the particles are just moving around, but it's still H2O particles. That's a key thing right here. I'll pause it for a sec. Go. So here are a couple examples of physical changes. You guys don't have to copy this down. Copy down the equations, but you don't have to write the models down. If you want to go back later, and you guys can fill those in if you want to watch this before a test or quiz. These are good things that I'd expect you guys to figure out how to do in a test or quiz. But so write the equations down, and I will explain those momentarily. So evaporation is when H2O liquid, that's an L right there, that stands for water liquid, becomes H2O gas. So notice that the H2O particle is the same before and after. That's what makes that a physical change. And notice that the particles in a liquid are close together and they separate. They change position. But what actually happens to the individual water particles? What happens there? They stay the same. It's still made of one oxygen. Oxygen's the red atom, and the little white ones are hydrogens. So the water molecule still is intact. Hammering copper into a cube, into a flat sheet, that's a property called malleability, which you might have heard. That's a physical change. Why is this a physical change? Anyone want to take a stab? Why do you think, Jesus? Why is this physical? Nope. What about the particles? What happens to the particles of copper? They change position, but they're still the same copper particles. That's why it's a physical change. Moving forward, and we're almost done with this. Chemical changes. Now, chemical changes are different. Hydrolysis is the breakup of water. Hydro, meaning water. Lysis, meaning to break. It's when you break water apart. This is one of the first big experiments in chemistry. So notice that you have a water H2O particle, and you have the atoms switch their partners. They're switched with who they were in the beginning. Here you had hydrogen bonded to oxygen, and in the end you have oxygen bonded to oxygen and hydrogen bonded to hydrogen. Okay? Very important reaction, and actually Mr. Costa demonstrated this earlier in class today, was combustion in our Bunsen burner. In the Bunsen burner, we have methane gas, which is natural gas. Anyone here who has gas stove at home? Gas stove? That's natural gas. That's CH4 methane, which is actually a colorless and odorless gas, and they have to put something in there to make you smell it if there's a gas leak. So that's there as a safety precaution. But that reaction is when methane reacts with oxygen gas in the atmosphere, and you end up with CO2 and H2O, also the products of respiration. So you see, to start, you have your carbon atom, which is the black one, and your hydrogen, which is white again. they're bonded together in groups of CH4, and oxygens together. In the end, you have carbon bonded to oxygen and hydrogen bonded to oxygen. So notice that those particles changed. The atoms changed who they're with. And that's the key idea about a chemical change. Okay? So let's, I'll quickly sum this up. Physical changes, particles change position, but the particles themselves are intact. A chemical change, the particles themselves are changed. You have a new substance in the end in the products as you did in the reactants. All right? That's all we have for today. Hold on, I haven't dismissed you guys yet. And, oh, is it time to go?
Hey guys, when you leave, you need to put your chairs up.
When all the chairs are up, guys, that's when we can go.